Okay, morning. I'm going to start with going through the homework. I got it completely wrong. I think I was thinking of my second years when I said we didn't have class till Thursday. Obviously, we have class today. Okay, so graph the following lines and find the point of intersection graphically. The first part. So to graph the lines, I need them with y isolated. So 3x plus 4y equals 27. And I want y isolated. So to get rid of the 3x, which is a plus 3x, we do minus 3x. That will cancel it out. And then minus 3x on the far side. So then we have 4y equals minus 3x plus 27. Still trying to isolate the y. So we divide by 4, divide by 4, divide by 4. Ugh. It's not going to be an easy one to plot. So it's minus 3 over 4x and then plus, I'm going to need this as a decimal that I can plot, 6.75. Okay, so it's not ideal when they're decimals, but it does happen. This is, see, they do this a lot, right, where they ask you to find it graphically when it's awkward, like a 6.75 start. And the reason they do it then is because then your algebra can be so your algebra is the more accurate one, because obviously there's no human error, there's no me trying to plot this, it's literally just, here's the algebra. So, yeah, so they actually do this quite a bit where it's an awkward one. So you kind of do your best to do the most accurate point of intersection you can graphically, and then your algebra kind of swoops in and gives you the correct answer. So we will do our best with this, and I'll show you how to kind of make sure that you do it as close to perfect as possible. So I'm going to go ahead and do the other one before I plot them. I'm going to do one in blue and one in black, and then I'll plot them. So 3x plus y equals 18. Okay, same thing, I'm trying to isolate the y. So again, we have a plus 3x, so minus 3x will eliminate that. And then we minus 3x on the far side. Tidy up gives us y equals minus 3x plus 18. And that's it. The y doesn't have a number in front of it, so it's already isolated. Okay, that went all right. Now, right, I need, is that as small as they go? I wonder. Okay, so I need 18 here. And then obviously 6.75 is, I can't quite figure out if I need negatives. I don't think so. Right. Okay, so I'm just looking at my slopes. So on the left I have minus 3 over 4, and on the right I have minus 3. So they're pretty small. So I think I'm going to try go up in 2 boxes. On my x-axis. And I don't think I'm going to need the negative, but I'll fill it in anyway. Shh. Dog is getting angry at his own reflection. Okay, now the y-axis. Okay, so this is where my problems are going to be. So I need 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. Yeah, I think I'm going to have to do that. Okay, so we're going up in twos. 2, 4, 6, 8, 10, 12, 14, 16, 18. I don't know if I need to go higher than that, so we'll just go to 22. That's my y, and then again go down. Oh, not minus 3. Minus 4. Minus 6. Okay, I don't think I'm going to need it, so I'm going to stop there. Right. So I'm going to plot the first one. So the first one, I have a very awkward start point of 6.75. So let's see, can I get this as accurately as possible? So that's 7. Agreed? So 6.75 is going to be 3/4 of the way up this line. So about there. Sorry, I did the blue line. I've zoomed way in on my iPad. Ooh. See the blue line? So the blue line is kind of like halfway. So then I did a blue dot just above that. Okay, so it's not perfect, but it's as good as I can do. Now let's look at my slope. So for my slope, it's a fraction, which is great. I have a rise. Note that the rise is negative. And I have a run. Okay, so we're going to run first. We're going to run 4. And then we're going to rise -3, which means we're going to go down 3. Okay, so run 4 should be fine. I'll put the dots in and I'll take them off. So 1, 2, 3, 4. Can you see them just about? Now I'm going to go down 3. So I'm going down 3 from 6.75. So that's going to be to 3.75. So that's about there. So you go from 6.75 to 5.75 to 4.75 to 3.75. Does that make sense? So this is where it's awkward because we're going down 3, but we're going down 3 from 6.75. So you can't kind of count the boxes. So if this is 6.75, we drop down to 5.75, then to 4.75, and then eventually to 3.75. Okay? I'm going to take all that middle stuff out. So I have my dot. What colour was this? This was blue, wasn't it? Draw, blue, insert, line. So I'm going to put this on the dot, which is at 6.75. I'm going to put it through my 3.75 there. Yeah, so I think all the inaccuracy is going to come from this one, but we'll keep going. Okay, now this one. So much easier start point, albeit big, which is annoying because it made my graph harder to make accurate. But I'm starting at 18. I can actually pop that in just, you can just see the top of it there, 18. So I'll put that in there. Now my slope is not a fraction, so I need to make it a fraction. So now I have a rise. Again, it's negative, and I have a run. So I'm going to run 1. I'm going to rise -3. Okay, so I think you should be able to see this. So run 1 brings me to there, and then rise -3 is 1, 2, 3. Yeah? So there are the 2 key dots. I'm going to take the rest out. And I'm going to put in my black line. And I'm going to see if I can get these to intersect and what kind of number I'm getting. There's 18. I need to go through. So I'm trying to go through the yellow dot here, but I'm extending the line so that it cuts the other line. Yeah? Right. So my key point is down here. Obviously, I'm just focusing on where they cross over. So this is where the algebra is going to help. I might actually do it with, let's go with red. Insert and go with an arrow. So I'm going to try and line this up and just kind of point at where I'm supposed to be. Looks about right. So here is 1.5. That's 1.25, so would you say maybe 1.2? So I think maybe 1.2 for that one. and then we go green and insert, and then like that looks pretty close to 5, doesn't it? I'm going to say 5 for that one. Now, so like I said, once we saw that 6.75, this was never going to be perfectly accurate. This was never going to cross over right in the corner of the box. So in an exam, what an examiner is expecting you to do is literally what I've done here. I drew the graph as accurately as I possibly could. I concentrated to try and get my 6.75 as close to what I think 6.75 is. I drew my lines, I got them to intersect, and I looked at the point of intersection, and I've now found the x value of it and the y value of it. So that is my graphical value. And now what I'm going to try and do is get an algebraic value. Okay, that's the second part of the question. So let's go back and do that. So it says graph the following lines and find the point of intersection graphically. Done. And I got 1.25. So I'm just going to write that in there so we can refer to it. And then use simultaneous equations to find the point of intersection graphically. Okay, sorry, algebraically. So the first step is to write the lines in the form y equals, as in isolate the y. So I've got that done already. So here it's y equals minus 3 over 4x, and I'm going to use the fraction version, not the decimal version. So 27 over 4. Right, that's the first one. And the second one was y equals minus 3x plus 18. So I'm going to write that down. Y equals minus 3x plus 18. Is that okay? Okay. The second one then, we let y equal y. So I'm going to let this version of y equal this version of y. So I get minus 3 over 4x plus, am I still on the board? No. Plus 27 over 4 equals minus 3x plus 18. Okay, that's the equate. Now, the third step is to solve, but we don't solve a fraction. So if there are fractions, you get rid of them by multiplying across by the common denominator. The common denominator here is 4. So I'm going to multiply by 4. So multiplying everything by 4, I multiply here. Oh, no, sorry. I need green. So I multiply here by 4. I multiply that one by 4. I multiply that one by 4. And I multiply that one by 4. Yeah, so the brackets are kind of indicating multiplication. So first one's grand. The 4 and the 4 cancel. And I've got minus 3x. Second one, the 4 and the 4 cancel, and I've got plus 27. Third one, there is no 4 to cancel, so we'll just do the multiplication, which is minus 12x. And the third one, there's no 4 to cancel, so I just do 18 times 4, which is 72. Okay, now I'm going to gather, so I'm going to bring the x's, it doesn't really matter, but I'm going to bring x's left, and I'm going to bring the numbers to the right. So this is meant to be on the left, so I'm going to plus 12x to get rid of it from this side, and I'm going to plus 12x to bring it over to the other side. This one is in the wrong place, so I'm going to minus 27 to get rid of it from that side. Am I? Yes, I am. And then I'm going to minus 27 to bring it over to the far side. Okay, so if we tidy up, we have minus 3x plus 12x is 9x. And then over here we have 72 minus 27, which is 45. I want the x, so I need to divide by 9, cancel that out, and x equals 5. And actually that's what I got, isn't it? No. My God, how am I that far off? I got a y value of 5. Okay, we'll keep going. Maybe I made a mistake in the plotting. Okay, so we need to sub that back in then to the first equation. So the first equation is 3x plus 4y equals 27. So 3x plus 4y equals 27. And we're going to change the x into a 5. So it's 3 times 5 plus 4y equals 27. 15 plus 4y equals 27. Trying to isolate the y. So we minus the 15, minus the 15. So 4y equals 12. Oh my god, this is working out perfectly. Oh, I've definitely done something wrong in the graph. We'll have to go back and have a look. So divided by 4, they cancel, and I'm getting that y equals 3. So that is x first, so 5. So I'm getting 5, 3. Now, while there's license to be off, there's not license to be off that much, so I think I must have done something wrong. 3x plus 4y equals 27, minus the 3x, minus the 3x, and then is it my, oh my god, sorry, I think I did it on both lines. Okay, so I don't think there's anything wrong with my rearranging. It's my graphing. I hope you were shouting at me when I was doing it, so I'm going to fix it now. So the 6.75 is fine, the 18 is fine. I think what I did wrong is I forgot that I did 2 boxes for my x-axis. Pretty sure that's what I did. So my 6.75 is still here, my blue dot, and I need to run 4. Now, running 4, oh crap. So running 4 is 1. Don't know why I did that, hang on. So 1, you see that? Yeah. 2, 3, 4. There's 4. And then I go down to, I go down 3. So that's from 6.75 down to 3.75, which I did correctly, I think. So that's about, there's 3.75. I didn't do my run, like the easy part. It's fine, we're going to fix it. So blue, insert, line. Okay, that's that one. And then the other one, the 18, was a run of 1 and a rise of -3. So again, I don't think I ran far enough because it's a double jump. So there's a run of 1. And then -3 is 1, 2, 3. Okay. So then draw. And I'm going to draw my line. I'm going to go through the yellow dot and I'm going to extend. I'm not getting anywhere near 5, like. Or maybe I am. 5, 3 is what I'm supposed to be getting. Like that is about 2.25. -3x plus 18 is right. So -3x, we run 1. Oh my god. What's wrong with me? Having a bad morning. So run 1 I'm happy with. And then we need to go down 3. So down 3 from 18 is 15, for goodness sake. Okay, see, does this make a difference? I can actually only laugh. Okay. So I might need to extend my blue line maybe. So I'm not even looking at where it's crossing the blue line. I'm concentrating on the yellow line. Oh, I am just about crossing. Cool. Okay. So here's my crossover. So about there. Let's try and move that slightly. So it's straight. There. Okay. So that looks like, if that bit there is 5.5, is that 5.2? Something like that. And then draw, red, insert, arrow, and then try and grab the point of intersection and go across. Keep it as horizontal as possible. I think it looks just less than 3, maybe 2.9. So 5.2, 2.9. Wow. Okay, so that's acceptable. So 5.2 to 5 and 2.9 to 3. Do you know, I was going to go back and re-record this video without making a mistake plotting the graphs, but one of the reasons why you do this in an exam, one of the reasons why it's asked in an exam, that normally the algebraic one is to verify your graphical answer. So like, you'll make these mistakes. Like, if I can make these mistakes, anyone can make these mistakes. I want to show you what an acceptable error is. Okay, so I knew instantly that I had done something wrong somewhere. And it is really, really important. If this happens to you, I mean, obviously if it happens in an exam, but you want to get into the habit of this. So if this happens to you in your homework and your algebraic answer is giving you 5.3 and you've checked it and you're pretty sure it's right, and your graphical answer is way off, like mine was, go back, give it, like, I don't know what that took me, maybe 6 or 7 minutes to fully realize what my mistake was. I mean, it's so easy to make mistakes, but what's important is that you fix them. So I'm pretty confident now that I have fixed my graph, and I remembered that my x-axis went up in 2 boxes and my y-axis 1 box was 2 jumps. I just kind of forgot about my scale. Like, it can be, yeah, I think sometimes when I was so focused on that 6.75 and trying to show you how to plot a decimal, because we haven't done that before, that I sort of forgot about, you know, the scaling and stuff like that, which is no excuse. I just shouldn't forget it. But the reason we do a verification, like an algebraic verification, is to, you know, kind of prove that a graph has been plotted correctly. So the fact that I got 5.2 up here and the real answer is 5, and I got 2.9 up here and the real answer is 3, that would now lead me to believe that my graph is correct. And the error is coming from the fact that I'm working with a graph and decimal values. Okay? Right. So this chapter is basically finished, or it will be now in about 10 minutes. Simultaneous equations, you have to be able to do word problems. So that's what we're going to do now. Okay, so x is going to be the cost of 1 apple, and y is going to be the cost of 1 orange, and x and y are measured in cents. And 2 apples and 2 oranges cost 76 cents, and we need to write an equation for that. Okay? So we have 2 apples costing x cent per apple. So if each apple was 10 cent, for example, if you to work out the price of 2, you would do 2 multiplied by 10 cent. You'd say 20 cent. So that's why I'm using multiplication. 2x is 2 multiplied by x. So it's 2 multiplied by the cost of an apple plus 2 multiplied by the cost of an orange, and together they make 76 cent. And then b I have 5 apples, so 5 multiplied by the cost of an apple, plus 2 oranges, which is 2 multiplied by the cost of an orange. Now it equals €1.21. This needs to be in cent, so we're going to go 121. Okay, we can't have mixed. It says that the x and the y is in cent, so we need our answer to be in cent as well. Okay, and then it says use your answers, or use your equations even from part A and B to find the cost of each fruit. So I need to solve these two simultaneously. And that will give me the cost of each fruit. So I need to take the first one. Sorry. And isolate y. Sorry. So minus 2x minus 2x. And then I have 2y equals minus 2x plus 76. And then we divide by 2, divide by 2, divide by 2. They cancel. They actually cancel. Oh, sorry. So the first one's cancel, the second one's cancel. So I'm left with y. And then I have minus x. And then 76 divided by 2 is plus 38. Just give myself a bit more room. So that's the first one. Second one is 5x plus 2y equals 121. And again, trying to get this. So same process, minus the 5x to cancel, minus the 5x to balance. So 2y equals minus 5x plus 121. And then divide by 2, divide by 2, divide by 2. So we get y equals minus 5 over 2 plus, no, I don't think there's, no, oh my god, of course it doesn't. Okay, so that's my first step, isolate y in both cases. Now I let y equal y, so I'm going to let minus x plus 38 equal minus 5 over 2x plus 121 over 2. If there's fractions, get rid of them by multiplying by the common denominator, which in this case is 2. So I'm going to multiply this one by 2, that one by 2, that one by 2, and that one by 2. Okay, so the first one is 2 multiplied by minus x, which is just minus 2x. Second one is 38 times 2, which is 76. Third one, the 2's cancel. So I have minus 5x. And in the last one, the 2's cancel. So I have 121. Okay. I'm going to bring the x's to the left. So this is in the wrong place. So I'll plus 5x to get rid of it from that side. And I'll plus 5x to bring it over here. And then this is in the wrong place, so I'll minus 76 to get rid of it and minus 76 to bring it over there. So this is 3x, and this is 121 minus 76, this is 45. And then we divide by 3, divide by 3. So I get 15. So x is 15. Okay, and then I need to sub back into the first equation. 2x plus 2y equals 76. So 2x plus 2y equals 76. And I'm going to make the x equal to 15. So it becomes 2 times 15 plus 2y equals 76, which is 30 plus 2y equals 76. Really didn't leave myself enough room for this one. Oh, it's working. Okay, I have to shut down. Open it back up again. See, does that help? We're doing so well. Well, besides me making a mess of the questions. come on. Okay, excellent. So we need to isolate that y. So we minus the 30, minus the 30. So 2y is 46. And then we divide by 2 and divide by 2. So y equals 23. So x is 15 and x was the cost of the apple. So from here we get that the apple is 15 cents. And then y was the cost of the orange. So the orange is 23 cents. Okay. So like it looks really long. It's just the same. It's just a simultaneous equation. So you use the words to turn it into equations, and then you go through your process of solving simultaneous equations. Now, I'm not going to go through the actual solving part here. I'm just going to do the start of this, writing the equations, because the last time x and y stood for the cost of something, it was money. It's slightly different when, see here, x is the number of adults and y is the number of children. Okay, so 30 adults and children visited the cinema. So there was 30 in the group. Part A wants us to write an equation in x and y. So that means the number of adults present plus the number of children present equals 30. Okay, so I call this the number of equation. And it's almost always followed by a costing equation. Okay, look at the next bit, tickets cost. Okay, so just watch what we have to do here. So tickets cost €5 for an adult and €3 for a child, and the total cost of the visit was €114. So each adult, and there was X of them, paid €5 for their tickets. So we take the number of adults and we multiply it by €5 to get the cost of the adult tickets. Then each child that attended, and there was Y children, paid €3 for their tickets, and in total that came to €114. That's the costing equation. And more often than not, that's how the first one is unusual, where it was just all costing. Normally it's a mixture of number and costing. Okay, and then you would go ahead, isolate your y's, equate, get rid of any fractions, solve for your x, and then sub to solve for your y. Okay, I will finish it, but I'm not going to do it on screen because it's just the same thing again. So I'll finish it so that you can see it in your notes. So for homework, what will we do? I don't know, question 1 and 2? Haven't looked at these in a while, so I can't remember if they're even very difficult, but we'll give question 1 and 2 a go. So Tuesday the 30th of November, there's question 1, back up to simultaneous, and there's question 2. Okay, so they're for homework, and that is for Friday. Hopefully I'll be able to correct them in person. Alright, thanks guys.